to the management. By that, the equipments can be serviced. So second comes under IoT enabled shops, airports, and station. So in the right here, the smart services and tracking system is applied. For example, smart checkout or flight updates will be available in that. So IoT enabled mobile services also available in this. So smartphones control and the monitoring devices. Example, I can say it as controlling home appliances using a phone. So that comes under IoT enabled mobile. By means of mobile, we can control wherever. For example, so we'll be knowing that by using IoT, we can control the devices from anywhere. So next thing, the edge IoT devices and edge IoT device and IoT devices. Devices process the data locality before sending it. Example, smart center analyzing the data instantaneously. So it will be sensing the data and it will be given to the devices. So next comes under the data centers. So this data centers plays a major role a major role in that it can store and process a large amount of IoT data. For example, these data centers, otherwise called, we can call it as cloud system. So in this cloud system, we can analyze uses the data. For example, it can take for a year how much of power is generated during January till December. So depending upon that data, we can be uses the power. So next, transport. Excuse me. Next, the transportation system is smart ships, planes, and trains for tracking and safety purposes. For example, GPS tracking of all the. For example, the IoT can be used for uses in vehicles for using GPS tracking system where the vehicle is moving and going somewhere. IoT enabled cities such as called as smart cities, we can say it as such as traffic lights and service around the automation. So by using this IoT like traffic lights, so where, for example, we are traveling in a road, so by that we can see the traffic where it was huge. By that we can see the alternate road to reach that place at a virtual time. So IoT enable home buildings such as smart homes and automation systems. Example, automatic light and temperature control systems will be there. So this the IoT enable homes and buildings. For example, the smart system had been introduced at home. Will be entering inside the room by means of sensors. It can be lights and fans can be turned on and turned off. Again, depending upon the temperature room, it will be differs and can be used. So it comes under the components of smart grid. So in this, what are the components that are used? Smart meters, sensors and IoT devices, communication interface, infrastructure, data analysis and platforms. So in smart meters, devices that measures electricity using the real time and communicate data to the utilities. For example, a smart meter shows your hourly power consumption and help you to reduce during peak hours. This monitor the grid conduction of voltage, temperature, and faults and sends the data automatically. So communication and infrastructures, the network that concentrates all devices and enables the data transfer. So it includes technologies like Wi-Fi, fiber. So this we have already seen. For example, Wi-Fi, fiber optics, 4G, 5G, and WiMAX. For example, smart meter sending uses data to control centers via wireless networks. So data analytic platforms. In this data analytic platforms, we can use right here as a software systems that can analyze and collect the data to make the decision and predictions. So all the data can be collected right here. So by means of that, for example, I previously told the power can be generated from January to December. So during next year, we can predict only this much of power we can be generated. So by means of that, how we can reduce the demand. During that analysis can be done by this data analytic platforms. For example, this is prediction high electricity demand and adjusting supply to avoid backouts. So right here you can see the generation and transmission as a sub transmission distribution to the customers. So right here we'll be using SCADA, the phasor measurements, facts and advanced conductors. So again from the substation. So between substation, distribution automation and distribution circuits of the future. So to the customers we'll be using advanced metering and demand responses and distributed resources. So these all things will be seeing under next slides. So next comes under IoT enabled smart meters. So what is smart meters? We have already seen before slide. Right now the IoT enabled smart meters. So right here the digital meter with the communication capability. So digital meters communication capability, it will be using some IoT technologies again like Wi-Fi and cellular etc. to connect with utility systems. So allow two-way communications between the user and the electricity provider. So these are the digital. This is there in the digital meters with communication capability. Next, measures electricity consumption in real time. So right here it will be taking as track energy usage instantaneously instead of monthly readings. So then and there it can be track the readings, it can be recorded automatically. So it helps the users see when and how they can consume electricity. So this all comes under measure electricity and consume in real time. So it sends data to utilities automatically. So that means whatever power will be generated or whatever will be usage, how much of power will be generated, where it is wasted. So these all things can be by sending. It will be sending data to data. It will be sending the data to automatically. No data for manual meter reading. So the data is transmitted regularly to the electricity company directly. So support dynamic pricing. So this is the very main thing in this. So right here the electricity cost changes based on time. For example, peak time will be one type of cost, and off peak time it will be one type of cost during daytime, night time. So the peak time will be comes under right now. So right from morning will be not using much electricity during time of 1 to 4 hours or 1 to 3. At afternoon will be using, for example, due to heat will be using some ACs and ACs, fans, lights, everything will be using during that time. So during night time also will be after 6 will be peak load. So during that time the cost can be reduced by means of this. So encourage users to use the power when rates are lower. So for example, in household uses a smart meter that shows high usage in the evening at peak time. So electricity costs more during this period. So family shifts activities like laundry to the late night, soft peak time to save money. So these are the things they can be used by using this IoT enabled smart meters. So next we can see here is the smart meter data flow. So from this home devices and the smart meters, utility services and the control centers. So home devices, what inside the home, what it is there. So everything will be used by the home devices. The smart meters, so already we have seen before, the utility services and the control centers. So in the control centers, everything, whatever devices we are using, whatever the meters are there. So meters will be taking the reading, what is the voltage, what is the current value, or what is the voltage fluctuation, what is the losses are there, everything will be right there we can see. So in utility services, how much will be used, that comes under utility services. So these all things will be controlled by this control center. So the below diagram you can see the data is encrypted and sent to how MI works, right? So that comes under advanced meter interface, that is comes under that is called as AMI works. So utility receives the data regularly in the irregular intervals. Receiving uses data may be actively to view through an online portal. Excuse me. So these all things can be measured by measuring smart meters. For example, in foreign countries, everything are come everything. For example, water, gas, electricity. This all comes at the means of pipelines. So how much of things will be used by means of fuel? So everything is calculated by this by means of the smart meters, smart meter data flow. So we'll be seeing the advantage of smart meters. So in this advantage of smart meters, there will be having accurate billing. In this accurate billing, real-time monitoring, reduce operational cost, improve customer awareness, right? So what is called as accurate billing? So right here, accurate billing is based on actual electricity usage, not estimated. Actual usage, what we are using, that comes under the accurate billing. So it can be estimated. So depending upon, so this electricity usage will be varied. It not will be same for date every day. For example, day one will be using for watching TV will be spending 2 to 3 hours. For example, if it is a holiday, we'll be watching movies by means of TVs and all. By during that time, the electricity usage will be getting increased. So that time during we cannot estimate the cost during that time. Reduce billing errors and disputes. The real-time monitoring, using this real-time monitoring system, we can use the track energy using consumption instantaneously and help it better control and energy saving. So this will be done in real-time monitoring system. Again, I'm saying that users can track energy consumption instantaneously, helps in better control of energy saving. So reduce operational cost. How will be reducing operational cost means no need to for manual meter reading. If there is manual meter reading, we no need that. So lowers labor and maintenance cost of for utilities. So improved customer awareness. For improving customer awareness, customers understood their usage patterns. So encouraging efficient and responsible energy reuse. So how we can be use energy efficiently. By that, the power can be consumed. So by consuming that power, how we can be reuse that power. So this can be by using this improved customer awareness. So next comes under energy monitoring system. So how can be the energy can be monitored, right? So first thing comes under track energy consumption patterns. So how we can track it? For example, continuously records energy usage over time. For example, hourly, daily, and monthly. So this can be recorded during hourly, daily, and monthly. So it helps identify peak usage periods and wastage trends, right? So we can take a data of hourly, daily, and monthly thing. By that, by that track energy consumption patterns. Useful of planning energy saving strategies can be done by using this track energy consumption patterns. So next, identify ineffective devices. So we can identify the ineffective devices like detect appliances that consumes more power than normal thing. So, for example, where we are consuming more power, for example, we can take example. I can say it as iron box. By using that iron box will be ironing the cloth during that time because sorry. So because of that, we'll be consuming high power. So high outages or faulty equipments helps the user replace or optimize high energy devices. So this all comes under identify inefficient devices. So enable productive maintenance, right? So this comes under enable predictive maintenance comes under For example, we can say it as companies. Companies will be doing that predictive maintenance oftenly. For example, either it is two-wheeler or car will be you will be giving services then and there. So why we are doing that means, for example, we'll be traveling by means of long distance. So by means of that, something can occur by some fault can be occur in the vehicle. So for right here, they enable predictive maintenance, like so they can analyze, use data to detect for unusual behavior. They predictions possibility failures before they occur. So reduces downtime and maintenance cost. So before we can see, so it can reduce the cost and it can reduce the cost and downtime also. Provide energy usage analysis. So it generates detailed reports and visual insights. So this provides as the energy usage analysis. So it helps to compare past and current consumption, what we have used. So this supports a better decision making for energy efficient. So these are the things can done by energy monitoring system. By this can be power can be saved there. So right here we can see the data. Right here we can see the data management system, energy management system, consumers, renewable energy and batteries. So right here you can see the arrow marks of the data meter data management system. So it will be it will be sending the data. It will be recording and monitoring everything by means of usage per day, what we are using by means of home, or by means of renewable energies, what the power will be generated. So this all can be done by meter data management system. So it can be either send the data, or it can be, for example, how much of power is generated. So from this power generation, what is the demand is there. So it will be checked by means of the system. So everything is monitored by the energy management system. So from this energy management system, where the power is less, by that, so it can automatically self-heals, can be used by that. So next thing comes under benefits of energy monitoring. This comes under improved energy efficiency, reduce operational cost, better decision making, environmental sustainability. So right here, how we can improve energy efficiency means help to reduce the wastage by optimizing usage. By using optimizing usage, we can improve the efficiency, reduce operational cost, likewise, lower electricity bills and maintains expenses. So that comes under reduce operational cost. So better decision making provides the data to plan and manage the energy use efficiently. That comes under the better decision making. So environmental sustainability, it reduces energy consumption, low carbon emission. So that comes under environmental and sustainability will be using. So renewable energy integration. So this thing may know during what is renewable energy integration. So renewable, that is that, but reusable, that comes under renewable. For example, solar with wind integration. Solar with renewable solar with the wind integration, distributed energy resources, IoT monitoring for enabled plants, so grid stabilization management. So right here, solar and wind integration combines the solar panels with the wind turbine with the grid power. That helps to generate clean energy and reduces demand on fossil fuels. Right. So next comes under distributed energy resources. A small scale energies like rooftop solar panels, some batteries, etc. So this comes under DER. So distributed energy resources located near users to improve efficiency and reliability. For example, small rooftop solar panels. For example, the rooftop solar panels can be fixed anywhere it can be fixed anywhere instead of in the rooftop. So if it is fixed in somewhere else while transmitting, again we'll be getting some losses. So to reduce that, we'll be placing a rooftop. So IoT monitoring for enabled plants. So energy sensors, so uses sensors to track performance for solar and wind systems. So that comes under IoT and monitoring for enabled plants. So and also it enables a real-time monitoring and quick fault detection can be occurred. So it can be detected. Okay, that comes under IoT monitoring of enabled plants. So enables, again repeating, enable real-time monitoring and quick fault detection can be find out by means of this IoT monitoring system. It comes under grid stability management. So grid stability management is the important thing that comes under maintains the balance between energy supply and demand. That comes under grid stability management. So prevents voltage fluctuations and fault outages previously. So that comes under prevents voltage fluctuations and power outages. So these are the grid stability management you can done. So next we can right side you can see the enable integration with smart grid. So right here you can see the wind on the solar plant and the power plants and power plants and combined heat and power. So again from the transmission distribution network, the smart buildings and smart meters. So this all interconnected with this data. You can see below. You can see that data network and the power grid lines as smart meter systems. So what I have connected then and there you can very visual. So next comes under challenges in renewable integration. So challenges in renewable integration comes under intermittent energy generation. So what is called as intermittent energy generation means the solar and wind, depending upon weather conditions, it will differ. Not will be the same for the entire day or the entire month and the entire year. No, it won't. It cannot be same. It will keeping on changing between the intermittent energy generation. The energy production is not a constant or are not predictable, right? So wind and for example, solar and wind can be predicted during daytime and it cannot be predicted during daytime, nighttime, how much of power is generated. So depending upon that. So the next grid stability issues. So what comes under grid stability issues means, so main thing comes under fluctuating power supply is the main thing. You cannot distribute to the grid balance, right? So keeping on voltage fluctuation is there. We cannot give to the grid directly. By if we are giving that to the grid directly, again the components will be what in between what will be there. It all comes under damage. So main causes comes under voltage and frequency variations will be there. When the voltage and frequency is keeping on varying again and again, so we will be getting trouble with that. So energy storage requirements. So in this energy storage requirements, excess energy needs. Exclusive energy needs to be stored for a later use. So that comes under energy storage requirements. So in this energy storage requirements, so whatever the power will be generated, the excess power is stored by means of batteries. So that comes right here. So requires batteries or other storage systems which can be costly, right? For example, be saying the power in this battery. Power, so it will be, for example, battery will be very high. So we cannot put the battery for saving them in there. Complex grid maintenance. So there is a very complexity for maintaining the grid maintenance. So integrating multiple energy sources increases system complexity. Requires advanced control systems and smart meters is required for this complex grid management system. So next comes under demand side management system. So the demand side management system. Sorry, demand side energy management. Demand side energy management.
Kartishwari ma'am, please mute yourself, ma'am. Your mic is unmuted. Thank you.
Demand side energy management. So in this demand side energy management, will be seeing energy control energy usage on consumer side, increasing energy efficiency behavior, use of smart applications, load balancing strategies, right? So in this, the control energy usage on customer side. So by managing how and when the customer use electricity, so that comes under control energy usage on customer side, right? So reduces unnecessary consumption during the peak hours. So this can be controlled by controlled energy usage on customer side. So encouraging energy efficiency behavior. So it promotes habits like turning off unused devices and uses incentives to reduce power usage. Usage of appliances like devices automatically adjust energy uses. For example, smart ACs and the washing machines. For this will be for purchasing will be getting the 5-star rating devices. So again, let's consider operate efficiently based on demand and pricing. So when it comes to load balancing strategies, distributes electricity demand evenly across time, shifts usage from peak to off peaks hours to avoid overload. So next, demand side management. So in these smart applications, smart meters, and utility control devices and the energy optimization can be done uh, by means of this smart site management. So right here we can see the smart management system by using internet and by using HEG will be monitoring, alarm control, logging, and management systems. They can be controlled. All can be controlled by means of this HEG value that comes under our internet portal. So from that can be energy storage and the scheduled applications and non-scheduled applications. So again, that comes under the electrical vehicle right here. So during these things, we can say that demand side management. So right here, where the power will be demanded will be cannot be assumed that. So it is keeping on increasing day to day life. So whenever we'll be using, we really don't know that. So again, the power will be keeping on increasing in this. So this comes under demand response program. So in this demand response program, peak load reduces, dynamic pricing models, dynamic consumer incentives, automated load control. So these things will be there in this. So IoT technologies used right here. So where we'll be using this IoT technologies means wireless sensor networks, RFID technologies, edge computing and cloud computing will be used in this IoT technologies used. So in this usage, for example, wireless sensor networks will be using network of sensors that collect and transmit the data wirely, used for real-time monitoring systems. For example, sensor in a smart grid monitoring voltages and the energy usages. So then RFID technologies uses the radio wave to identify and track objects very easily. So enables automatic data collection without contact. Example, I can say it as RFID tag used in a smart meters for identification and billing. So next, edge computing. The process data near source instead of sending everything to the cloud. Reduces delay and improves response time. Example, I can say it as a smart meter analyzing the energy usage instantaneously to detect faults. Next, cloud computing stores and processes a large amount of data over the internet, allows the remote access and advanced analysis. For example, for this, for example, cloud computing is it as utilities combines using cloud platforms to analyze consumer energy data and generate reports. So that's concerned right here. So next next we're going to see under communication protocols. So that comes under Zigbee, LoRaWAN, and NB-IoT, Wi-Fi and 5G. Wi-Fi and 5G. So Zigbee gives a low power, short range and communication protocols will be using. So these communication protocols will be using for for commuting to devices from one to another. So LoRaWAN is kind of low range, low power network for IoT applications. Work well, works well in wide areas like cities and rural regions. Examples of smart meters sends the data to utilities over a long distance time. So NB-IoT comes under narrow band IoT. So narrow band IoT, cellular based low power communication technologies designed for reliable data transmission with low bandwidth. For example, utility companies writing the meter data while mobile networks. So that comes under your narrow band IoT. So Wi-Fi and 5G right here comes under high speed wireless communication technology can be used for transmitting the data and getting the data where we'll be using, for example, data consumes and wherever the data is needed. For example, demand is needed. Enable fast data transfers and enable connectivity. The example is smart meter systems with Wi-Fi and 5Gs for instantaneous monitoring and control can be used. So this comes under data analytics with smart grid. So right here we'll be using big data processing, predictive analysis, fault detection, and demand forecasting. So how we'll be using this thing by means of data analysis means, for example, big data processing, utility companies processing daily electricity usage of thousands of homes, right? So that comes under handles large volume of energy for smart meters and sensors, helps in storing and managing, analyzing the data efficiently. Predictive analysis uses past data to predict future events or trends. It helps in planning and preventing issues. So it comes under preventive analysis. For example, predicting peak electricity demand during summer. Fault detection, it detects the sudden voltage drop, including a line fault. So that comes under fault detection. Demand forecasting. So in demand forecasting, estimates a future energy demand based on patterns. It helps balance supply and demand, that comes under demand forecasting. So next we will be seeing under cyber security in smart grid. So cyber attack, so this comes under data encryption, secure community protocols, authentication mechanisms, network security monitoring. So in this data encryptions and converts data into secure form to prevent the unauthorized access, and it ensures privacy of energy usage information. Example, I can say it as encrypted smart meters data before sending it to the utility services. So secure community protocols, they use a safe method to transfer data between devices and systems. So by this, so this all can be interconnected with the cyber security devices. For example, for this, you can be using secure protocols like HTTPs for data transfer. Authentication mechanisms, it verifies the identity to user and devices. It prevents authorized access from the system. For example, I can say a authentication mechanism comes under smart meter requiring login credentials or digital certifications. Network security monitoring continuously monitors the network files, threats, or usually activities. So it helps the data, it helps the detection and respond to the cyber attack quickly. For example, detects the abnormal data traffic, including a hacking attempt, right? So cyber security is a major main thing in smart grid. For example, the total power can be shut down by total power can be controlled by means of this cyber security. So this can be happened. So next comes under advantages of IoT based smart grid. So these advantages of IoT based smart grid comes under improve energy efficiency, reduce carbon emission, real-time monitoring, and enhance grid reliability. So from this I can say that achieve through real-time monitoring and smart control to encourage users, reduce the wastage by monitoring supply and demand, reduce carbon emissions comes under achieved by integrating renewable sources like solar and wind, and minimize the reliance on fossil fuel. Real-time monitoring comes under achieved using IoT sensors. Smart meters can be done in real-time monitoring and provides indent data on the energy usage and grid performance, engagement grid reliability, advanced achievement through automated fault detection and quick response system. So ensure the stable and continuity power supply can be done with this advantage of these are the advantages that can be done by use of IoT based smart grid. So limitation challenges. So this limitation challenges high implementation cost. So during this high implementation cost requires expensive smart meters, sensors, and communication systems are needed for this high implementation cost while installing of smart meters and all. Installation maintenance cost also very high. For example, if any meter is damaged, again we need to replace that. So that time the meter again the service cost and the meter cost is very high. The risks. Connected devices are vulnerable to hacking and cyber attacks. Unauthorized access can disturb the grid operation also. For example, from outside people, they are controlling the total grid by means of a single thing. So by that, the total power can be controlled. Complex infrastructure. So the complex infrastructure involves integration of multiple technologies and smart meters, difficult to design and manage and maintain in the complex infrastructure. So next comes under data privacy concerns. So in this data privacy concerns, collects the data, user energy, and uses data, risks of unauthorized sharing of personal information. So that comes under data privacy concerns. So next comes under future trends. So in future they can be integrated by means of AI with smart meters. So advanced energy storage system can be done. Then blockchain technologies can be included for the energy trading. The 5G enables of our IoT networks. So these are the future trends. It can be done by means of the smart grid, to control the smart grid. So in case study, they can done by using the smart grid deployment comes on a large scale meters installations, integration with renewable energy. So energy savings and efficient improvements. So these are the case study can be done in smart grid deployment. So in research opportunities, so nowadays they are doing under smart grid optimization, IoT based predictive maintenance, so energy trading platforms, advanced demand responses and systems. So by this I can conclude that IoT plays a critical role in modern smart grids, improves monitoring, control and efficiency, enables sustainable energy management, supports integration for renewable energy. So thank you.
Thank you, sir. On behalf of Sriram Engineering College, I would like to express our sincere thanks to our STM resource person for the insightful and informative section on IoT for smart grid and energy management. Your valuable time and knowledge have greatly enriched our understanding. Thank you, sir. Now, we would like to open the floor for interaction. If any of the participant or faculty members have questions or clarification regarding today's section, you are welcome to ask them now. If there are no questions, we'll proceed further. Thank you once again, sir, for the informative session. Thank you all for the active participation and interaction in today's session. Within this, we come to the end of the day 3 of 6-day online faculty development program on emerging trends in IoT. We look forward for a participation in tomorrow's session. So feedback form is posted in the WhatsApp group. So kindly complete the feedback form to get your attendance recorded. Thank you once again to our resource person, organizing team and all participants for making today's session successful. Have a great evening. Thank you.
Thank you, sir.
Thank you, sir.